So let's make this real. Let's look at some actual Spark code to make a decision tree using MLlib that can actually scale up to a cluster if you wanted to. It's actually pretty simple. Let's take a look. All right, let's actually build some decision trees using Spark and the MLlib library. This is very cool stuff. I'm in Florida and we're currently getting a Florida thunderstorm, so if you can hear any rain in the background, I'm not sure if the mic's picking that up, but apologies if so. Just think of it as soothing, relaxing background noise. So wherever you put the course materials for this course, I want you to go to that folder now and make sure you're completely closed out of Canopy or whatever environment you're using for Python development, because I want to make sure you're starting it from this directory. Okay, and find the Spark decision tree script and double click that. And up should come up Canopy or whatever you're using to edit your Python files, and here we have it. Now, up until this point, we've been using IPython notebooks for the course, but you can't really use those very well with Spark. With Spark scripts, you need to actually submit them to the Spark infrastructure and run them in a very special way. And we'll see how that works shortly. So we are just looking at a raw Python script file here without any of the usual embellishment of the IPython notebook stuff. So let's walk through what's going on in this script. Go through it a little bit slowly here because this is your first Spark script that you've seen in this course. So we're going to import from pyspark.mllib the bits that we need from the machine learning library for Spark. We need the labeled point class, which is a data type required by the decision tree class, and the decision tree class itself, imported from mllib.tree. And now pretty much every Spark script you see is going to include this line where we import Spark conf and Spark context. And this is needed to create the Spark context object that is kind of the root of everything you do in Spark. And finally, we're going to import the array library from NumPy. And yes, you can still use NumPy and scikit-learn and whatever you want within Spark scripts. You just have to make sure, first of all, that these libraries are installed on every machine that you intend to run it on. So if you're running on a cluster, you need to make sure that those Python libraries are already in place somehow. And you also need to understand that Spark will not magically make the scikit-learn methods, for example, magically scalable. You can still call these functions in the context of a given map function or something like that, but it's only going to run on that one machine within that one process. Okay, so don't lean on that stuff too heavily, but for simple things like managing arrays, totally an okay thing to do. So we'll start by setting up our Spark context, and we start by giving it a Spark conf, a configuration. So this configuration object says I'm going to set the master node to local, and this means that I'm just running on my own local desktop. I'm not actually running on a cluster at all, and I'm just going to run in one process even. I'm also going to give it an app name of Spark Decision Tree, and you can call that whatever you want, Fred, Bob, Tim, whatever floats your boat. It just is what this job will appear as if you were to look at it in the Spark console later on. And then we will create our Spark context object using that configuration, and that gives us an SC object we can use for creating RDDs. Now let's skip down a bit past these functions that I have. We'll get back to those later and go to the first bit of Python code that actually gets executed in this script. So the first thing we're going to do is load up this pasthires.csv file, and that's the same file we used in the decision tree exercise that we did earlier in this course. So if you remember right, we have a bunch of attributes of job candidates, and we have a field of whether or not we hired those people or not. And what we're trying to do is build up a decision tree that will predict would we hire or not hire a person given those attributes. So again, make sure you change the path to that file to wherever you actually installed it. Otherwise, it won't work. Now let's take a quick peek at that file. Now you can see that Excel actually imported this into a table, but it's comma-separated values if you were to look at the raw text. The first line is the actual headings of each column. So what we have here are the number of years of prior experience, is the candidate currently employed or not, number of previous employers, the level of education, whether they went to a top-tier school, whether they had an internship while they were in school, and finally the target that we're trying to predict on whether or not they got a job offer in the end of the day. So we need to read that information into an RDD so we can do something with it. So let's go back to our script here. So the first thing we need to do is read that in, and we're going to throw away that first row because that's our header information, remember. So here's a little trick for doing that. We start off by importing every single line from that file into a raw data RDD, and I could call that anything I want. Again, this is an arbitrary name I made for it. But we're calling sc.textFile. Spark Context has a text file function that will take a text file and create a new RDD where each entry, each line of the RDD consists of one line of input. Now I'm going to extract the first line, the first row from that RDD by using the first function. So now the header RDD will contain one entry that is just that row of column headers. And now look what's going on here. I'm using filter on my original data that contains all of the information in that CSV file. And I'm defining a filter function that will only let lines through if that line is not equal to the contents of that initial header row. So what I've done here is I've taken my raw CSV file and I've stripped out the first line by only allowing lines that do not equal that first line to survive. And I'm returning that back to the raw data RDD variable again. So I'm taking raw data, filtering out that first line, and creating a new raw data that only contains the data itself. With me so far? Okay, it's not that complicated. Now we're going to use a map function. And what we need to do next is start to make more structure out of this information. So right now, every row of my RDD is just a line of text. It is comma delimited text, but it's still just a giant line of text. And I want to take that comma separated value list and actually split it up into individual fields. So at the end of the day, I want each RDD to be transformed from a line of text that has a bunch of information separated by commas into a Python list that has actual individual fields for each column of information that I have. So that's what this lambda function does. It calls the built-in Python function split, which will take a row of input and split it on comma characters and divide that into a list of every field delimited by commas. Okay, so the output of this map function, where I passed in a lambda function that just splits every line into fields based on commas, is a new RDD called CSV data. And at this point, CSV data is an RDD that contains, on every row, a list where every element is a column from my source data. Now we're getting close. Now it turns out that in order to use a decision tree with MLlib, a couple of things need to be true. First of all, the input has to be in the form of labeled point data types, and it all has to be numeric in nature. Okay? So the next thing we're going to do is transform all of our raw data into data that can actually be consumed by MLlib. And that's what this create labeled points function does. So we're going to call map on CSV data, and we are going to pass it the create labeled points function, which will transform every input row into something even closer to what we want at the end of the day. So let's look at what create labeled points does. It takes in a list of fields, and just to remind you again what that looks like, let's pull up that CSV file again. So at this point, every RDD entry has a field. It's a list, a Python list, where the first element is the years of experience, second element is employed, so on and so forth. The problems here are that we want to convert those lists to labeled points, and we want to convert everything to numerical data. So all these yes and no's need to be converted to ones and zeros. These levels of experience need to be converted from names of degrees to some numeric ordinal value. So maybe we'll assign the value 0 to no education, 1 can mean BS, 2 can mean MS, and 3 can mean PhD, for example. Again, all these yes-no values need to be converted to zeros and ones, because at the end of the day, everything going into our decision tree needs to be numeric. And that's what create labeled points does. So it takes in this list of string fields and converts it into labeled points, where the label is the target value, was this person hired or not, 0 or 1, followed by an array, remember that's why we imported np.array, that consists of all the other fields that we care about. So this is how you create a label point that the decision tree MLlib class can consume. So you see here that we're converting years of experience from a string to an integer value. And for all the yes-no fields, we're calling this binary function that I defined up here, and all it does is convert the character yes to 1, otherwise it returns 0. So y's will become 1s, n's will become 0s. Similarly, I have a map education function I defined that converts different types of degrees to an ordinal numeric value. Okay? So at this point, after mapping our RDD using that create labeled points function, we now have a training data RDD. And this is exactly what MLlib wants for constructing a decision tree. Let's create a little test candidate we can use so we can use our model to actually predict whether someone new has been hired or would be hired or not. So what we're going to do is create a test candidate here that consists of an array of these values for each field. So again, we need to map these back to their original column representation. So that 10-1-3-1-0-0 means 10 years of prior experience, currently employed, 3 previous employers, a BS degree, did not go to a top tier school, and did not do an internship. And we could actually create an entire RDD with more than one value if we wanted to, but we'll just do one for now. So we'll use parallelize to convert that list into an RDD. All right, now for the magic. We are going to call decisiontree.train classifier, and this is what will actually build our decision tree itself. We passed it in our training data, which is just an RDD full of labeled point arrays. Num class is 2, because we have basically a yes or no prediction that we're trying to make. Would this person be hired or not? The next parameter is called categorical features info, and this is a Python dictionary that maps fields to the number of categories in each field. So if you have a continuous range available to a given field, like the number of years of experience, you wouldn't specify that at all in here. But for fields that are categorical in nature, such as what degree do they have, if any, for example, that would say field ID 3, which maps to the degree attained, has 4 different possibilities: no education, BS, MS, and PhD. And for all the yes/no fields, we're mapping those to 2 possible categories: yes or no, or 0 and 1 is what we converted those to. We're going to use the Gini impurity metric as we measure the entropy as we go down our decision tree. A max depth of 5, which is just an upper bound on how far we're going to go. That can be larger if you wish. And max bins is just a way to trade off computational expense if you can. So it just needs to at least be the maximum number of categories you have in each feature. And now, remember, nothing really happens until we call an action. So we're going to actually use this model to make a prediction for our test candidate. So we use our decision tree model, which contains a decision tree that was trained on our training data, and we're telling it to make a prediction on our test data. And we'll get back a list of predictions that we can then iterate through. So predict returns a plain old Python object. It is an action that I can collect. Let me rephrase that a little bit. Collect will return a Python object on our predictions. And then we can iterate through every item in that list and print the result of the prediction. We can also print out the decision tree itself by using the toDebug string, and that will actually print out a little representation of the decision tree that it created internally that you can follow through in your own head. So that's kind of cool too. All right. Feel free to take some time, stare at this script a little bit more, and digest what's going on. But if you're ready, let's move on and actually run this beast. So to do so, you can't just run it, okay? We're going to go to the Tools menu and open up a Canopy command prompt. And this just opens up a Windows command prompt with all the necessary environment variables in place for running Python scripts in Canopy. And you can see my working directory here is the directory that I installed all of my course materials into, so make sure that's the case here. All I need to do is call spark-submit. So this is a script that lets you run Spark scripts from Python, and then the name of the script, spark decisiontree.py. That's all I have to do. Hit return, and off it will go. And again, if I were doing this on a cluster and I created my Spark conf accordingly, this would actually get distributed to the entire cluster. But for now, we're just going to run it on my computer here. So you can see in the test person that we put in there, we have a prediction that this person would be hired. And I've also printed out the decision tree itself. So it's kind of cool. We can walk through this and see what it means. So we actually ended up with a depth of 4 with 9 different nodes. And again, if we remind ourselves what these different fields correlate to, the way to read this is if feature 1 in 0. So that means if the employed is no, if this person is not currently employed, feature 5, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5. Okay. So this person is not currently employed, did not do an internship, has no prior years of experience, and has a bachelor's degree, we would not hire this person. But if that person had an advanced degree, we would, just based on the data that we had, that we trained it on. So you can work out what these different feature IDs mean back to your original source data. Remember, you always start counting at 0 and interpret that accordingly. Note that all the categorical features are expressed as in, this list of possible categories that it saw, whereas continuous data is expressed numerically as less than or greater than relationships. So there you have it, a working decision tree created using Spark and MLlib. Pretty cool stuff. And what's really cool is that this could scale up to a massive data set potentially. And it's pretty easy to use still. So there you have it. And there you have it, an actual decision tree built using Spark and MLlib that actually works and actually makes sense. Pretty awesome stuff. So you can see it's pretty easy to do, and you can scale that up to as large of a data set as you can imagine if you have a large enough cluster. So there you have it.